Hello, everyone, and welcome to section 2.3 in Precalculus, Polynomial and Synthetic Division. So, in order to understand how to do long division using x's, you really have to kind of know how to do it with numbers first. So I am going to do a brief example. If you think you already know how to do this, then you're welcome to skip ahead on through this. But just as an example, if we had 43 being divided into 1,000 and, or let's say 106,541. When you're trying to do it, the first thing you do is say, does 43 go into 1? It does not. Does it go into 10? It does not. Does it go into 106? It does. So because it goes into 106, we're going to write down how many times it goes into 106, which would just be twice. And then you would do 2 times 3. So 2 times 3 is 6. And then 2 times 4 is 8. After you do the multiplication, you would subtract, and you would get 20. Notice I wrote the 2 over the first thing that it went into. I didn't write the 2 over the 1 or the 0. I wrote it over the 6. Then you bring down the 5, and then you ask yourself, how many times does 43 go into 205? And this is what you're going to like actually better about using x's, is that you don't have to try and figure it out. It's going to be much more obvious. But in this case, it's 4 times. So 4 times 3 is 12. I'm going to have to carry. 4 times 4 is 16, but I'm going to write 17. And then you subtract, and you get 33. Bring down the 4. How many times does, and so on. So we're going to do this exact same operation, but we're going to do it with x's. And I think it's easier. So I'm going to write the x minus 2 here. You really have to be neat. This is going to be all about neatness and precision. And then I'm going to write 6x cubed minus 19x squared plus 16x minus 5. There's my original. So the question is, how many times does x go into 6x cubed? What's super nice is that unlike this one where you had to actually sit there and say, how many times does 43 go into 106? And maybe be a little bit good at math, you never have to do that with this one. You can always just off to the side do 6x cubed divided by x. You can always do the first thing divided by the first thing, and that'll actually give you the answer, 6x squared, every single time. So because it's an x squared, I want to keep all my x squareds in the same column. This is going to be my x squared column. Do not deviate from this or you will struggle. And then do you guys remember what we did next? We multiplied. So you're going to do 6x squared times negative 2 and get negative 12x squared. And then 6x squared times x, 6x cubed. Okay, do you remember that? We did the 2 times the 3 and then the 2 times the 4. We got an answer. And then what did we do? We subtracted. So I'm going to subtract. Sorry, just trying to line that up for us to make it a little easier to read. So I always recommend to kids that they subtract in a different color. That way you can make sure that you can look back on your work and say, oh, I did remember to subtract. Because what's hard is that there are 2 terms and both have to be subtracted. You're subtracting the whole thing. But I don't recommend that you do it using parentheses. I recommend you just change both. So this becomes a minus and this becomes a plus. I see the different color and it lets me know that I've done it correctly. Going back to my work, I add these now. So I get negative 7x squared. Do you remember from our number problem? And then you bring down. Now, some people can just look at this and say, what times x is going to make negative 7x squared? It's going to be negative 7x. But if for any reason you can't do that, you can take the first thing that you're trying to get and the first thing you're dividing by, and actually do the little tiny division, and that will always give you what to put next. Now I multiply. Negative 7x times negative 2 is positive 14x. Negative 7x times x is negative 7x squared. They need to come out identical, not opposite. It's easy to think you want it to be opposite so they cancel, but the reason they're going to cancel is because you're going to subtract. And when you subtract, that changes this to a plus, and it changes this to a minus. So again, I always change my color to make sure that I know that I've done it. This should cancel, and you get 2x. Bring down the 5, which is negative. And now I have 2x divided by x, which is just 2. But again, you can always do it off to the side. 2x, the minus 5 doesn't matter. Divided by x, the negative 2 doesn't matter. Gives me 2, so that's what goes next. And then I multiply. 2 times negative 2 is negative 4, and 2 times x is 2x. I change my color so that I can change this to subtraction and this to addition. And then I get negative 1. Now, you're either a junior or a senior now. I do not want you to write remainder negative 1. Okay, that's grade school. So if you're still doing that, you need to stop that. If you have 16 divided by 3, think about what that does. 3 goes into 16 5 times, but instead of saying remainder 1, because we're all grown up now, we would say 5 and 1 what? 1/3. 16 thirds is 5 wholes, each one of these being thirds. So now I have 9 thirds, 12 thirds, 15 thirds. It's going to be hard to do. And there's my 16 thirds. 5 wholes and a third. So the answer to this one is 6x squared minus 7x plus 2 and negative 1 over x minus 2. Not as easy to see conceptually as the 1/3, but you can use this concept to help you get the right answer. Okay? Now, it did have some odd directions in this section. It said for each one, write the answer in this form. First of all, I just need you to know I love the way I did it in a box because that makes the most sense to me. But your pre-calc book has this strange way they want you to do it. They want you to say that 6x cubed minus 19x squared plus 16x minus 5 is... Now, do you remember that when you changed 5 and 1/3 back to 16 thirds, you did 3 times 5 plus 1? That should be a little thing you remember from elementary school. So 5 times 3 plus 1, that's what they're asking you to do. They're saying do it as x minus 2 times 6x squared minus 7x plus 2 minus 1, meaning this times this minus 1 would actually produce that original answer. Do I actually care if you do this? No, if it says divide and you put the answer that's in the box, that's fine. But I don't want you to be confused by the way your book is having you do it. This is where they're getting this. So now you know. Let's do another one. Okay. If your problem is missing a column, like this one's missing the x squared column, you need to write it and fill it in with a 0. It's also missing the x column. And then there's the number. So if you start at cubic, you need cubic, squared, linear, constant. Okay, so off to the side, my first term is an x cubed, and I'm dividing by an x. I get x squared. So I need to write that in the x squared column. Next step is to multiply x squared times negative 1. Oh, actually, I'm going to write the answer real quick so that if you choose to work ahead, you're like, I got this. She's going way too slow. There you go. Okay. And then x squared times x is x cubed. Change the color to subtract. Make sure you subtract that second one. That's where people go wrong. And then you get 0 plus 1 is 1x squared. Bring down the 0x. X squared divided by x is going to be 1x. You don't really need that 1. I'm just trying to show you. So the first thing is an x squared and the first thing is an x. That's how I knew to do that. And then I multiply. X times negative 1 is negative 1x. And x times x is x squared. I change the color so that I can make sure I subtract both of them. And I get, this should cancel. That was the whole reason that you did that. And then 1x, and now I bring down the 2. Look how nice and organized this is. If you do it organized, you'll be thankful. The first thing is an x. The first thing I'm dividing by is an x. That gives me 1. After you figure out what goes there, you multiply. 1 times negative 1 is negative 1. 1 times x is x. It's really tempting at the end not to do this last step, but continue to change the sign. And I get, that cancels 3. So the answer would be 3 over x minus 1. And I love this answer. However, your book in some sections will ask you to write it as, not that, x cubed plus 2 is equal to x minus 1 times x squared plus x plus 1 plus 3. And again, where do they get that from? From when you have something like 4 and 3/5, that's the same as 5 times 4, 23/5. And the little mechanism by which you've always done that is 5 times 4 plus 3. So that's what this is doing. X minus 1 times x squared plus x plus 1 plus 3. Do I need you to do that? No, but in that section of your homework, you need to recognize those answers. Number 3. So this is ironic. This one's going to look a little longer, but it's actually not that bad. 2x to the 4th, 4x to the 3rd, minus 5x squared plus 3x minus 2. I just remembered I'll write up the answer. For anybody that wants to see if you can do it on your own, you know I love it when you try and do it on your own. 2x squared plus 1, x plus 1 over x squared plus 2x minus 3. All right, let's do it. So I have the first thing I'm trying to divide is 2x to the 4th divided by x squared is 2x squared. I put that in the x squared column. Then I multiply. 2x squared times negative 3 is negative 6x squared. 2x squared times 2x is 4x cubed. 2x squared times x to the 4th is 2x to the 4th. I go through with a different color and I change all the signs. And then I add. This is 0. Ooh, this one canceled too. And then this one became 1x squared. I bring down the 3x. And now I have, my first thing is an x squared. And, okay, this is going to sound really silly, but I feel like I need to switch this to red just because that's how I was doing it. And I want to be consistent. 1x squared. I didn't actually change it to red. But I was just trying to be consistent because I think it helps you more. Plus 3x. So I take my 1x squared and I divide by the first term over there, which is an x squared, and I get a 1. So what column does that go in? That goes in this column way over here. It's a number. It doesn't have an x. So when 2 of these canceled, we ended up skipping a spot. Make sure you also skip a spot. make sure you put a number in the number spot. Only x's go in this spot. But what that means is I'm going to have to bring down also the -2 because the 1 times the -3 needs a column. It needs this column. And then 1 times 2x is 2x. And then 1 times x squared is x squared. I change the signs. This becomes minus. This is plus. It becomes minus. And this is minus. It becomes plus. That gives me 1x plus 1 for a final answer of 2x squared plus 1 with a remainder of x plus 1, which we write over x squared plus 2x minus 3. In the same way that if you had 17 over 5, you would write that as 3 wholes, and then 2 what? 2/5, because that's what you're dividing by. So since you're dividing by x squared minus 2x minus 3, that's what goes in that part of it. Again, if your book writes it as 2x squared plus 1 times x squared plus 2x minus 3, you do not have to do this, but don't let it throw you either. Okay, that's what the original polynomial 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2 is equal to. So it's another version of the answer. All right, that's long division. That's all the examples I have for you on long division. Hopefully you got it after just 3. So there is a shortcut for dividing linear polynomials, and it's called synthetic division. I find this is the one thing people remember from Algebra 2 because it's kind of fun and kind of easy, but it only works for linear polynomials. So this is an example of something that's linear. It's x to the first power. So if you have this situation, you can actually write a -3 on the outside. So just like so many other things that we learned, this is going to be the opposite. So since it says x plus 3, we're going to do -3. And then I'm going to just put the coefficients here. 5, 18, 7, -4. Okay, so I put the coefficients. And then I use this little trick. I add these two things. Since there's nothing here, I'm going to add 0. And then I multiply. -3 times 5 is -15. Add, multiply. Add, multiply. Add, there's nothing left to multiply. So once you get to the end, then you have to change those numbers back into a polynomial. But it's going to be 1 less degree than it used to be because you've divided. So it used to be x cubed, now it's going to be x squared. 5x squared plus 3x minus 2. And you know you did it right if you get to the linear one here, because the last one is your remainder. The last one is the remainder. So that is 2, and what do you divide by? Same as before, whatever you're dividing by, x plus 3. Okay. All right. Let's try another one of these. On the outside chance you already have it, like you're like, oh yeah, I totally remember this. The answer to this one is x cubed minus 3x squared minus x plus 1 with a remainder of 1. Okay. I put a -3, remember opposite on the outside, and I do have to hold every place. So there's 1x to the 4th. There are 0 x cubes. There are -10x squareds, -2 for the x, and 4 for the number. Okay, So don't forget your placeholder. It will mess everything up if you forget it. And then the pattern is the same. We add, but there's nothing here, so I'm just going to add 0. And then we multiply. Add, multiply. Add, multiply. Add, multiply. Add. Okay? Now I change them back into a polynomial, but one lower than whatever it was before. So since it was x to the 4th, now this one's going to be x cubed. X cubed minus 3x squared minus x plus 1. And then the last one is always the remainder, which I can write as 1 over x plus 3. This is the opposite. And there's my answer. Most kids like it. It's kind of fun. One more. See if you can do it on your own. Let's see, we put a positive 1 there. My 4th is going to be a 1, but there's no cubes, no squares, no linears, and then the minus 3. Does that make sense? You have to do 1 for each one. And then the constant is always last. So I add, multiply, add, multiply, add, multiply, add, multiply, add. My answer is always 1 less power, so it used to be x to the 4th, so now it's x cubed plus x squared plus x plus 1 with a remainder of negative 2. And this is a plus. Almost got that wrong. Okay? That's synthetic. Unfortunately, it's way more fun, but unfortunately, you can only do it if this is linear. Only do if linear. If there's an x squared there, it won't work. All right. The remainder theorem says, if a polynomial is divided by x minus k, the remainder r is f of k. I know, math is so confusing, right? In plain English, that just means the remainder is the y value. So I'll show you on these. So if this is my function, f of x is equal to x to the 4th minus 3. If you wanted to know f of 1, then you could do it this way, and you would get negative 2. That number is the y value. Would I ever do this? No. If I wanted to know f of 1, I would just plug a 1 into my equation. 1 to the 4th is 1, minus 3 is negative 2. I would never do all this. But it is going to have some kind of usefulness to us as we continue to go on. Let's do another one. On this one, if f of x is x to the 4th minus 10x squared minus 2x plus 4, and I say to you, what is f of negative 3? The answer is 1. So in other words, if you put the x value right here, out pops the y value for any function. It is kind of cool. One more. If I wanted to know, actually, I'll just erase this. If this is f of x, oh, but that defeated my whole purpose. Can I go back? Because now I can't see the answer. There it is. So if f of x is equal to 5x to the 3rd plus 18x squared plus 7x minus 4, and I want to know f of negative 3, If -3 is what goes in the box, what pops out the other side is the y value. So synthetic division is great for dividing, but it's also great for this. And on this one, I have to tell you, if I had to plug in -3, I might be more inclined to do this without a calculator than actually plugging -3 into this equation. So how does that help you for graphing? Well, if you have a big problem like this, and you were going to put in a bunch of numbers, some of them you might choose to put in synthetically. So if I were going to plug in 0, I definitely would not do synthetic. 0 minus 0, 0, 0, -12. 2, 4, 6, 8, 10. So I can't even see it. If I were going to put in a 1, 1's not so bad. 1 minus 3 minus 9 plus 23 minus 12. Still not easy though, right? So let's see, what would I do? Ooh, these two make 24. And this is -12 and -12 make -24. I'm pretty sure that's going to come out to be 0. So when I plug in a 1, I get 0. But what if I wanted to plug in a 2? Ugh, now it's definitely getting harder, right? Now you might sit there and say, you know what? I am going to plug it in this way. 1, -3, -9, 23, and -12. So I can do this so much faster. 1, 2, -1, -2, -11, -22, +1, 2, -10. So at 2, I know it's right there. Now, normally, I would have everybody in the class do a different problem. I have no interest in in doing this on the video for you. This would take a long time. But normally I would call on like 5 different people, and I would have you do 3, 4, and then -1, -2, -3, and -4. But I am not going to ask you guys to sit there and do that with me. But I hope you can see that with the exception of 0 and maybe 1, if you had to plug in a number, especially a number like 3 or 4, this might be a better choice than this. So the question is this easier than doing f of 3 as 3 to the 4th minus 3 times 3 cubed minus 9 times 3 squared plus 23 times 3. Remember this without a calculator, because if this was really a question that you had on a test, it's got a graph, so it's going to be in the no graphing calculator section. So like I said, would have asked everybody in the room to do one. I will tell you that this is a 0 here, 4 is a 0, -3 is a 0, and since the basic shape is x to the 4th, which is a w, then I actually know that it comes down. Remember, the y-intercept is pretty low, so it comes back up. It actually bounces here, and then it goes down again, and it comes back up. It looks something like that. But we would have worked together as a class to do it. I'm not actually going to do it here, but I just want you to really think about when you need to plug in something for y, you might consider this in the future. Okay, the factor theorem. A polynomial f of x has a factor x minus k if and only if f of k is equal to 0. Again, let's put that in plain English. That means if you ever get a remainder of 0, then you have just found a factor. You have just found a 0. That's what we call those. You have found an x-intercept of the polynomial. Zeros and x-intercepts are the same, and they're always related to factors. So I'm just going to tell you that x plus 3 is a factor. So I'm going to put a -3 here. Remember, it's always the opposite. And then I'm going to write 1, 0. Don't forget, there's no x squared, so you still have to hold the spot. -19, -30. So remember, if something is factored, that factored tells you that's where the zeros are. But remember how it's always the opposite? If I told you that x plus 3 times x minus 2 made 0, it wouldn't be because of 3. It would be because of -3. So it's -3 that makes a 0. That's why it's the opposite. So this should produce a 0 because this is always the x, and out should pop the y. So I do this: 1, add, multiply, add, multiply, add, multiply, 0, just like I thought. No remainder. Okay? All right, now you ready for the cool thing? This is the cool thing. All right, so just so you know, two things. If something's a factor, so x plus 3 is a factor, then whenever you know a factor, you also know a 0, and you also know an x-intercept. But here is the second cool thing. This answer is the rest of the factors. So one of the factors is x plus 3, and then the rest of it is x squared minus 3x minus 10. That's why they wanted you to do this whole dumb thing in the beginning that at the time was like, who's going to do this? Who's going to write a polynomial as this? We are. Now that the remainder is 0, I'm going to write this as x cubed minus 19x minus 30. I've factored it. And can I find the rest of the factors? Sure can. X and x, 5 and 2, negative and positive, because my inners are 2x and my outers are -5x, and that would give me that -3x in the middle. Remember, you're unfoiling. The first times the first makes the first, the last times last makes the last, and the inners and the outers have to add up. So I have just factored this polynomial expression that you wouldn't normally know how to factor. And I can list all the zeros. The zeros are -3, -2, and +5. If they had asked for x-intercepts, then I would have said -3, 0, -2, 0, and 5, 0. Why is this so important? Because now I can literally make a graph of x cubed minus 19x minus 30. I always plot the y-intercept, so it's way down there at -30, because that's an easy point. And then the x-intercepts, -3, -2, and 5. 1, 2, 3, 4, 5. I know its basic shape is cubic, so now I know it must do this. Right? Okay, 30 is even lower. -30. Okay? So my point is that all of this is going to start to come together. And some of you might be feeling overwhelmed, saying, oh, this is so much. But the good news is it's like a puzzle, and all the pieces hopefully this year will come together. All right, now they're going to give me two factors. X, so this is going to factor into x minus 2 times x plus 3 times something else. We want to write it in completely factored form. We want to find the remaining factor. And once we find the remaining factors, we can list all the zeros. Listing all the zeros, we already know two of them, 2 and -3, but we're going to find the rest. How do we do that? We put in the first 0 that we know. This is definitely a 0. It's going to come out to be 0. 2, 7, -4, -27, -18. This had better be 0, because that's one of the ordered pairs. One of the x-intercepts is 2, 0. Another one is -3, 0. So 2, add, multiply, add, multiply, add, higher math here, 18, 36, 9, 18. Phew, that's like a little test there. All right. Big, big important point. Do not start over. Do not now put in the -3, because all that's going to do for you is going to give you another big, long problem that you can't finish. Instead, and this is just so cool, now you can put the -3 on the answer that you already got so far. I'll try and explain it without confusing you, but think about it like this. If you had 18 and you broke that down into 6 times 3, 3 is one of the factors and 6 is one of the factors, but then you could then start at 6 and break this down further. And then the factors would be 2 times 3 times 3. You wouldn't want to start all over again. It wouldn't get you anywhere. Once you've factored partway, you keep factoring. That's what we're going to do here. I've already factored with the 2. I don't want to start over. I want to keep factoring. So I get 2, add, multiply, add, multiply, add, multiply, add. And look, I got 0, which I expected because it says it's a factor. So I'm just going to erase this real quick. So what goes here? What is the last factor? The last factor is 2x squared plus 5x plus 3. I knew it was squared because it started as to the 4th power. And remember, you always reduce it by a power. Now it's to the 3rd, and now it's squared. Every time you do this synthetic division, it reduces it by 1 power. Now you do have to finish. So x minus 2 times x plus 3. So let's do our reverse FOIL. The only choices for 2x squared are 2x and x. I love when there's only one choice. And there's only one choice for 3, but it could be 1 and 3, or it could be 3 and 1. And to decide that, you need inners and outers have to make 5x. So I'm going to do 3 and 1, because that will give me 3x and 2x, which adds up to my 5x. First, outer, inner, last is how you factor. So this is f of x. Look what it was originally. And look, we factored it. It's so cool. I know you're not as excited as I am. And what are the zeros? The zeros are 2, -3. And on this one, if you can't do that in your head, you can just write it out. 2x minus 3, what would make that 0? Subtract 3, 2x is equal to -3 divided by 2 divided by 2. X is equal to -3 halves. Okay, so if you can't do it in your head, that's okay. So the next one is -3 halves, and the last one you can do in your head is -1. So find the remaining factors. Here were the remaining factors. List all the zeros. Listed all the zeros. All right, so let me just quick tell you a common error. I will not ask you to do all these things on one problem. I'll pick one. So you always have to read the directions. If it says write the function in factored form, then this would be the answer. If I say find the zeros, then this would be the answer. If I said find the x-intercepts, then this would be the answer. So you always have to be paying attention to what I'm asking you to do, because they are different questions and you can't just give me the answer that suits you. You must give me the answer that I'm looking for. All right, the next part says find the zeros of the following functions using your graphing calculator. So our first step is to type the equation into the calculator. you're going to use this y is equal to button that's now in red. It does say g of x. We never care. We're always just going to type in, y1. There's no g of x. So I use this caret button to make 2 to the third, and then you make sure you use the arrow button to go over to get down out of the exponent. Minus 4x. I don't use the caret 2. I use the little x squared button to make that. Minus 2x plus 8. I hit graph, and there I can see that there's 3 zeros. So I want to know what they are. So sometimes, actually that is not what I expected to look like. Did I type that in right? X cubed minus 4x squared minus 2x plus 8. Okay, so it looks like it's going right through 4. If you think you can see one, you can always go to the table, second graph, and I go down, and sure enough, look at that. At 4, it's a 0. So I just found one of the zeros without doing any work. If you can find them all just by looking at the table, that's fantastic. But you shouldn't find them all just by looking at the graph. You can't be positive that that goes through 0, goes through 4. It could go through 4.001. Now these other two, I definitely can't tell what they're doing. So I'm going to show you how to use the 0 feature. It's a calculation. So I'm going to hit second, calculate. And I'm sure you can see it. You want to go down to number 2, a 0. So the reason it asks for a left bound and a right bound is because there's 3 of them. It's kind of saying, well, which one are you trying to get? So I look at this and I say, oh, I'm trying to get the one between -2 and -1. So I type -2. Now do not use the subtract key or you'll get an error. Use the negative key. -2, enter, and -1, enter. And see, look, it made a couple lines for me. It's saying, okay, you want this one in between these 2 lines? And I'm like, yeah. I never guessed, just enter. So there it is. If you don't recognize that number, by the way, that number is -√2. But you can just write it as -1.414. Now I want to do it again. I need to find this next one. So I do second, calculate. You're trying to do a calculation. I either go down with the arrow, or I could have hit the number 2. Now again, it's going to say left bound. Well, this 0 looks like it's between 1 and 2. But you could also say it's between 0 and 3. You don't have to get really close to it. So I'm going to say 0 and 3. Okay, 0 is a little tough to see, but there's a little arrow at the top. But the 2 lines are the y-axis in this line is saying, okay, I'm going to find the one in between those 2. And you're like, yep. Do I make a guess? No. Whatever the calculator guesses is fine. And it's positive 1.414, which is positive √2. Okay, you can try the next one on your own, or you can watch for one more example. Y is equal to, I'm going to clear this one out, and I'm going to type this in. Now, I don't use S, so I'm going to use X. I just always use X. Minus 12x squared plus 40x minus 24. I hit graph. Oh, good, and I can see all 3 of them. It won't find a 0 if it can't see it. So that first one looks like it's between 0 and 1. So I'm going to go to calculate, 0, and I think the left bound is 0, and I think the right bound is 1. So it's saying I'm going to look between the y-axis and this line. I'm like, yep, I never guess. I just hit enter. There's your first 0, 0.764. The next one looks like it's between 1, 2, 3, 4, between 5 and 6. So I'm going to say second, calculate. I want to find the 0 between what's my left bound? 5, and my right bound is 6. I never guess. So I go like that. Oh, and look what it did. So the last 0 is actually right at 6. So I've actually found the third one when I was trying to find the second one. So then how do you find the second one? Well, to find the second one then, when I do this and I give it my left bound, I can still say I think it starts at 5, but I'm going to have to choose something less than 6. So let's choose 5.9. And then it will look in between those two. And the last 0 is 5.236. Okay, so that's how you find zeros using your graphing calculator. On the Slack section, it says mixed examples. That's because a lot of times kids' hardest part of this section is just understanding what the directions mean. So we'll do a few. Use the remainder theorem to evaluate. So this word evaluate means to find f of x given an x value. So if you had not been told to use the remainder theorem, you would have just found f of -2. And you're welcome to do that. 3 times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7. So if you would like to do that by hand, if this is in the no calculator section, the question is, which is faster? Putting a -2 in the box, 3, 8, 5, -7, or doing out this math? So I definitely think it's easier to do the one in the box. The numbers are smaller. 3, -6, 2, -4, 1, -2, -9. F of -2 is equal to -9. Would I have gotten the same answer doing it the other way? Yes. 3 times -8 plus 8 times +4 minus 10 minus 7, -24 plus 32 minus 10 minus 7. So these two give us 8 minus 17, -9. It's the exact same answer. I will confess, does anybody really use the remainder theorem? No, because people have a calculator so they can just type it in. This concept was a lot more popular before calculators because it definitely saved people time. What I really want you to know from this is two things. One is when it says evaluate, evaluate always means to find f of x given an x value. There is nothing wrong with doing it the way you've done it for years, but I'm showing you a shortcut if I put it on the no calculator section of your test. Number 2, use synthetic division to show that x is equal to -4 is a solution. So remember, normally when you're trying to find a solution, that means to solve. So if I said to you, solve x squared plus 5x plus 6, what would you do? You would factor it. X plus 2 is equal to 0. X is equal to -3 and -2 are solutions. That's what it's asking you to do. But we know that now, even though you've spent years learning this method, now I also know that I can say -4 is a solution if it produces a 0. Just like -3, when you plug it in, would produce a 0, a -4 will produce a 0. So let's test that theory. 1, ooh, did you remember the 0? Don't forget, there's no square term. Minus 28, minus 48. Add, multiply, add, multiply, add, what is that, 12, -12, multiply, 0. Okay, so I did it. I showed that it's a solution. Yes, -4 is a solution. And then it says, though, then use your result to factor. Solutions and factors are totally related. If x is equal to -4 is a solution, then x plus 4 is a factor. Just like here, -3 is a solution because x plus 3 is a factor. So now I know that this is one of the factors. What's the other factor? This is what's so cool. This is the other factor. x squared minus 4x. I know you're getting sick of me saying cool in math because you guys don't all think math is cool, but look at that. Come on, that's awesome. So x plus 4 times, remember, I'm going to do first, outer, inner, last. So the first times the first makes the first. The last times the last makes the last. But the inners and the outers have to add up to this. So I'm going to choose -6 and +2 because the last times the last has to make the last, and the inners and the outers have to add up to the middle term, which they do. So I used my result to factor the polynomial completely. So let me just erase this because I don't want it equal to 0. I want it to be the polynomial being factored. So here's the polynomial being factored. And then list all the solutions. So if this is equal to 0, x minus 6 times x plus 2. So I've taken this equation and I've rewritten it in factored form. And now that it's factored, the solutions are -4, +6, and -2. So I hope that this is really helping you see that factors and solutions, and then if you also wanted to call them, by the way, zeros graphically are the exact same thing as solutions. And x-intercepts are almost the same thing. We just write them differently because they're considered ordered pairs. And now I could literally graph that. It passes through -4 is an x-intercept, -2, and 6. 2, 3, 4, 5, 6. It does cross at -48. So I would just have to end up, like if you had a graphing calculator, it would just look like this. You couldn't actually see the y-intercept because it's at 0, -48. So on your graphing calculator, it would look like that. But I really hope that you're seeing how this all comes together. Verify that x minus 2 and x minus 4 are factors. If they are factors, then they would produce a 0. So -2, it doesn't matter which one you do first. 8, -14, ooh, -71, big number, -10, and 24. So let's see, 8, -16, -30, +60, -11, +22, +12, -24, and 0. I did it. Again, we did one of these earlier. Don't start over. Do it again. You've already got it partly factored. So x plus 2 times 8x to the third minus 30x squared minus 11x plus 12 is equal to f of x. But this isn't helpful because you can't factor that. So they gave you another factor. They're kind of like saying, okay, yeah, this guy, yeah, I know you can't factor that. I'm going to just tell you one of the factors. So you're trying to find this one. So you put in a +4 over here. Now I know it's confusing. Sometimes we take the opposite and sometimes we don't. This one, I didn't take the opposite because it says x is equal to -4. You only do the opposite when it's in factored form. So +4. So add, multiply, add, multiply, add, multiply, add. So now this is what's going to go over there. 8x squared plus 2x minus 3. It's still got a square, so I'm going to keep trying to factor. Now, they didn't tell me any more factors, so now I'm on my own. I'm going to have to do, I'm going to go with 4 and 2. I don't actually know. And then I have to do 3 and 1. So if I put a 3 here, I'll get 12 and 2. That's not going to make 2. So I think to myself, then it must be 1 and 3, or it's not factorable. And that gives me 2x and, oh, that's what I just had. Sorry. 3 and 1. That gives me 6x and 4x, which would give me that. If I make this one positive and this one negative, I will get the inners to be a 2x. There was a small chance that it was 8x and 1x, but that's pretty rare. All right, what did they ask me to do? Find the remaining factors. So I did it. They gave me these two factors. I found the remaining factors. And then completely factor it. So you can't just list the two underlined ones. They say completely factor. That would be completely factored. Completely factored. And then it says list all the real zeros. Once you have it factored, then the zeros are just -2, 4. Now, if you can't do it, remember, you can always actually set it equal to 0. Because that's what you're saying. You're saying this factor is at some point equal to 0. When is it equal to 0? If x is -3/4. That's one of the zeros. And for this one, if you can't do it in your head, that's okay. Set it equal to 0. 1/2. These are the zeros. Oh, I hope this is making sense to you. It's so hard not to be in class and watching your faces to see how it goes. But I certainly hope that that made some sense to you today. All right, you did it. Have a great day.